Hey everyone, I hope this video lecture finds you well. Um, as I mentioned in class, we will be having our first exam of the year upcoming. Um, hey everyone, hope this video lecture finds you well. Like I mentioned in class, we will have our first exam upcoming. If you're in B cohort, your exam will be this Friday. If you're in A cohort, your exam will be on Monday. So today, the purpose or the topic of this video lecture will be just Unit 1 review. So I'm going to go over each of the chapters we discussed, and I'm going to go over key points, key topics you guys really need to know from each chapter, as well as key vocab that you need to know from each chapter. So let's get started. All right, so the first chapter, we talked about the Earth's movements and we talked about the seasons. We talked about how in this image right here, you can see that the Earth is tilted at a 23.4 degree angle, and depending on which hemisphere is pointed towards Earth, the sun hits that hemisphere more directly. And in this case, the northern hemisphere is tilted most towards the sun, and you would have summer in that region, and then in the southern hemisphere, you would have winter. So what do you need to know from this chapter? You need to know everything. It'd be great to know everything, but the bare minimum that you will need to know for this exam is you need to know how the Earth moves. So the two ways the Earth moves is it revolves and it rotates, and you need to know the length of these times. So one revolution around the sun is 365.25 days. We call that a year. And then the length of time it takes for Earth to rotate once on its axis is 24 hours. We know that as a day. We also need to know that Earth's axis is tilted, and that's why we have our seasons. Remember, it's very important to know that it's not the distance away from the sun, because in actuality, when in January, the Earth is closer to the sun than it is in July. It's the way that the Earth is tilted towards the sun that causes our seasons. And once again, the tilt of the Earth is 23.4 degrees. Hemisphere tilted towards the sun is summer. Hemisphere tilted away from the sun is winter. And it's important to know the two vocab words up there, summer solstice and winter solstice. The summer solstice is the longest day of the year. The winter solstice is the shortest day of the year. It's also important to know the word equinox. We've talked about that a lot. We just had our autumnal equinox a few weeks ago. During the equinox, the length of day and night are equal to each other. So you guys will also need to know the vocab from the chapter. You've already done multiple assignments on this, but it's always good to review. Let me move my head, get that out of the way. So the first vocab word is axis, which is the imaginary line that runs through our planet. Rotation is the movement of Earth around its own axis. Revolution, movement of Earth around the sun. Remember, you need to know the length of those two terms. Rotation is a day, revolution is a year, 365.25 days. You need to know orbit, which is the path Earth takes around the sun. You need to know solstice, which is the day Earth is most tilted towards, if it's the summertime, or away, it's the wintertime from the sun. And then you need to know equinox. So neither hemisphere is tilted towards the sun. We have days of equal day and night. And that's everything you need to know for chapter 1. All right, so the second topic we discussed in this unit was Earth's moon. So what you need to know about Earth's moon is that Earth is an airless, dry place with an irregular surface. It is much less dense than Earth. Remember that Earth is the most dense planet in the solar system. Earth is densest at its core, and its outer layers are less dense, and the moon's density is roughly the same as the Earth's outer layers, which, like I just said, are less dense than its core. The The moon also has a 1/6 the gravity of Earth, so it's once again it's you would weigh much less on the moon than you would at Earth, just because the moon isn't as strong as Earth. And it's also about the quarter of the size of Earth as well. So it's much less dense, not nearly as strong, or it doesn't exert nearly as strong a gravitational pull, and it's much, much smaller. Very important here. The Earth, moon has no atmosphere. The Earth does have an atmosphere, obviously. It enables us to live. And one of the things that is so important about Earth's atmosphere is it traps in radiation from the sun, making it so that when the sun goes down, we don't freeze to death. The moon doesn't have that safety blanket. When in the darkness on the moon, it is very, very cold. And in the sunlight on the moon, it is very, very hot. So the surface temperatures on the moon vary drastically compared to Earth, and that's because it has no atmosphere. It's also important to know the characteristics of the moon's surface, which we spend a lot of time talking about. So you need to be familiar with Maria, you need to be familiar with the highlands and craters that make up the moon's surface. It's also going to be important that you know how long one revolution and how long one rotation takes on the moon. And you need to know that they are the same exact time. So Earth's moon takes 27.3 days to revolve once around the Earth, but it also takes the moon 27.3 days to rotate once on its axis. All right, moving on to the moon's vocab. So some important vocab words you guys will need to know are Maria, which are dark, flat areas formed from hardened lava that flowed 3 to 4 billion years ago. You'll also need to know highlands, which are lighter in color. So the dark areas on the moon are the Maria. The light-colored regions of the moon are its highlands. They're mountainous features that cover most of the moon's surface, and they cast dark shadows on the moon. If you had a telescope, you'd be able to see those shadows. You also need to be familiar with craters, large round pits that can be many miles across. These were formed by collisions with meteoroids, which are large chunks of rock from space. And that is this topic in a nutshell. All right, so that's all the review for the moon that you need to know. The final topic we discussed in class were tides. I'll move my head out of the way. So for the tides, what you guys need to know is you need to know how the moon and sun and their gravitational pulls are responsible for the tides that we have on Earth. So you need to know that water on the Earth closest to the moon gets pulled by its gravity. And when this happens, it creates a bulge on that side of the Earth. This tidal bulge travels across the Earth as it rotates. So you can see in this image, we have two tidal bulges right here. That's where high tide is on the Earth. Then we have two areas where the water is stretched thinner. So that would be where low tide is. And those aren't moving. They're staying in the same spot. What is moving is the Earth. So the Earth is rotating underneath those bulges, which results in our tides. You also need to know that most places on Earth experience 2 high and 2 low tides a day. You need to know the difference between a spring tide and a neap tide. So in a spring tide, the Earth, sun, and moon are all lined up. We have higher and lower tides than normal during a spring tide. And finally, you need to know neap tides. Oh, by the way, we have 2 spring tides per month, once during a new moon and once during a full moon. And finally, neap tide, it's when the sun and moon are at 90-degree angles from each other. When they're at 90 degrees from each other, their gravitational forces kind of cancel out, and we have tides that are less pronounced during this time. And that also happens 2 times per month, once during the first quarter moon and another time during the third quarter. All right, and some vocab that you guys need to know for tides, and then we'll wrap this video up. You need to know what a tide is. So the tide is just the rise and fall of ocean water. You need to know what a spring tide is. So when Earth, Sun, and Moon are all lined up, extra gravitational pull is put onto the Earth, which results in higher and lower tides. And then finally, we have the neap tide. When the sun and moon are at 90-degree angles from each other, gravitational forces are not aligned, causing less pronounced tidal changes. All right, so that's Unit 1 in a nutshell. We will definitely review more in class this week, but if you watched this video and you paid attention, you already kind of have a leg up and you'll be even more prepared than you were before. So if you have any questions about this video, please reach out to me. Like I said, we'll review more in class. So if you still feel a little iffy on any of this material, we'll definitely have time to kind of iron out those issues in class. All right, stay tuned for the next video.